Video assignment with Kirchhoff's current law.
Okay, so in this problem, we are going to use KCL or Kirchhoff's current law, which states that the algebraic sum of the currents in any junction or node of an electrical circuit is 0. So, what do you mean by node or junction? So, a node or a junction is the intersection of the currents in a circuit. So, in this specific circuit, where is the intersection of the currents? It's here, this one. Okay, so this is our junction. So we are going to apply KCL in. We're going to apply KCL at junction O. Okay, so now the direction that we're going to use is counterclockwise. Okay, so we're going to like that. So let's check. Everything that goes inside the node, okay, is positive. Okay, so that should be IB plus IA. Okay, since they are both going inside junction O, and the current L is going outside the junction O, so it's going to be negative. So this is our equation 1. Now we're going to apply KVL or Kirchhoff's voltage law on the big loop or the outside loop. So we're going to start here R P O N T S R, because as I said, we're going to go counterclockwise. So we're going to start here. It goes inside the source and then outside to the positive side. So it's going to be positive 24. Okay, and then we're going. As I mentioned, this is the voltage law. So we're going to find voltage, and the formula of voltage is this one: current times the resistance. So we have the current, I mean this one, and then we have the resistance. Okay, so that's going to be, okay. Oh, another law stated in another part of KCL is that when the current is in the same direction as the chosen direction or the assumed direction, then it's going to be negative. So the current here is going here, and also we are going counterclockwise, so it's going to be negative. Okay, we do not have the current, but we have the resistor, which is 0.4. So that's going to be 0.4 IB. Okay, and then if the current opposes the direction, then it's going to be positive. So as you can see, the current is going clockwise while we are going counterclockwise, so that's going to be positive. The resistance is 0.2, and we have IA. And then it goes here, it goes into the positive side and goes out into the negative side, so that's going to be negative 24. And the algebraic sum of all of this is equals to 0. Okay, so we're going to simplify. So negative 24 and 24, that's going to cancel out. So we're going to have 0.4 IB plus 0.2 IA is equals to 0. Now multiply both sides by -1. So we're going to have 0.4 IB minus 0.2 IA is equals to 0. So that will be our equation number 2. Okay, now we are going to apply KVL to the small loop. Okay, to the small loop. So we're specifically in this one. Okay, so we're going to do the R, P, O, S, and R. So R, P, O, S, and R. Go. So again, positive 24. Okay, and then it the current and the assumed direction is the same, so that's going to be negative. Okay, negative 0.4 IB, and then we're not going to continue here because again we're focusing on the small loop, so we're going to go down here. Okay, the current is still going counterclockwise, which is the same as our assumed direction, so that's going to be minus, okay, the resistance, which is 2, and IL is equal to 0. Okay, so we're going to transpose both of these to the right side. So that's going to be 24 is equals to 0.4 IB plus 2 IL. Okay, or you can write it as 0.4 IB plus 2 IL is equal to 24. Okay, so this is going to be our equation number 3. There we go. So now we are going to apply the elimination. Okay, so we're going to use both of these equations. We're going to eliminate one variable so that we can get the result and then eliminate it again with equation number 3. Okay, so it's going to be IB plus IA minus IL is equal to 0. So this is our equation number 1. And our equation number 2 is 0.4 IB, okay, minus 0.2 IA is equal to 0. There we go. So we want to eliminate one variable. So we cannot eliminate IL, okay, because we do not have an IL here. Okay, so the easiest thing to do here is to eliminate IA by multiplying the first equation with 0.2. So 0.2 will get distributed to all of these. Okay, so that's going to be 0.2 IB plus 0.2 IA minus 0.2 IL is equal to 0. Okay, and if I'm going to input the equation number 2 here, so this one, positive 0.2 IA and negative 0.2 IA will cancel out. So we're going to be left with 0.2 IB, 0.4 IB. So you're going to add those. That's going to be 0.6 IB and then bring down this one. So this is our equation number 4. Okay, and then we're going to use equation number 4 with equation number 3. So this is equation number 3. And equation number 4. So now what are we going to do here? Okay, we are still going to eliminate a variable. So what are we going to do? We're just simply going to multiply the equation number 4 with 10. Okay, 0.6 times 10, that's going to be 6. That's going to be 6. I'm going to copy the equation number 3 first. Okay, so again, it's going to be 6 IB plus, not plus, negative. This is the negative sign. And negative 2 IL is equals to 0. So positive, negative, same thing. So that's going to cancel out. Okay, 0.4 plus 6. So that's going to be 6.4 IB is equals to 24. Okay, divide both sides by 6.4 to isolate IB. So that is going to be 24 divided by 6.4. That is 3.75. So this is our IB. Now we have the value for IB. We can solve for the other values as well. So we can either use equation number 3 or equation number 2. Okay, so in my case, I am going to use equation number 2. So I'm just going to separate this first. So equation number 2. So this is equation number 2. So 0.44 IB minus 0.2 IA is equals to 0. Now we're going to substitute this value. So that's 0.43 multiplied by 3.75 minus 0.2 IA is equal to 0. So now we're going to input this in our calculator. So this is 1.5 minus 0.2 IA is equals to 0. Transpose this one. So that is going to be 0.2 IA is equals to 1.5. Okay, isolate IA. Yes. Divide both sides by 0.2. Okay, there we go. So 1.5 divided by 0.2, that's going, IA is going to be 7.5. Okay, so this is our IA. Okay, my ball pen is not working. So as I've said, that is our IA. This one. So now we are going to use equation number 1, since we have IB and IA, to find IL. So this is equation number 1. I hope you can see it because I'm using a pencil. So yeah, as I've said, equation number 1, IB, which is 3.75, 3.75, okay, plus IA, which is 7.5, minus IL, which is missing, okay, is equals to 0. And then transpose IL, that's going to be IL is equals to 3.75 plus 7.5. Okay, so now 3.75 minus 7.5, IL is equal to 11.25. So now we now know the values of the 3 currents, missing currents in the circuit.
Thank you and goodbye.